first time somebody asked me to do this. It's not me doing it. Instead, somebody else asked me to upload a video about sequence and series. So I think he wants it from the bottom to up, all the way, like everything. He wants everything, I think. At least I'm going to assume he wants everything. I don't know if he's like a bit advanced in this, or if he's just trying to learn this. Whatever it is, I'm just going to start from the basics. And yeah, whatever questions I think I need to elaborate on, I will try to explain it. So this might be a long video. Right, this video I'm just going to cover all the in chapter exercises. Let's start. So first thing is, okay, now we are ready. So the first question, if x plus 1 3x and 4x plus 2, these are the first three terms of an AP, okay, then the fifth term is, right, so no big deal. What's the common difference? The common difference is, well, x plus 1 2 3x, what is this, 2x minus 1, right? That's the difference. And from 3x to 4x plus 2, that will be x plus 2. Yeah, I think so. Yes. So that means that x is 3. So our difference, that will be 6 minus 1 is like 5. Okay. And these three numbers, they are 4, 9, and then 13. Yeah, that. Yes. No, wait. It's not 13. It should be different. Our x value is 3, right? No, our difference is 5 though. So yeah, it should be 14, I think, because 12 plus 2 14. Yes, that's correct. And then we want the fifth term. This is the first term, second term, third term. For the fourth term, it will be plus d, which is 5, so 19, and then 24. So 4 5. Fifth term is 24. Okay, next, the coefficient of x power 9 in this thing is right. So let's just try to see if we get some kind of pattern. So x into x minus 1, that will be x squared minus 1 plus 2x plus some other stuff which we don't care about, so plus all the constant, so it's like 1 into 2, but yeah. And then x minus 2, this will be, so first you multiply by x, you will get that x cube and stuff over there. Then you do this times x, so x squared, that will have that minus 1 plus 2, and then minus 2 times x squared, so it's like minus, it should be minus 3, I think, right? It's going to be minus of 1 plus 2 plus 3x squared, and some other stuff which we don't care about, right? So you see that the second leading term, that has the coefficient as negative of 1 plus 2 plus 3. So this was x minus 1 into x minus 2 into x minus 3, and you got this as this coefficient. You can similarly extend this to 100 terms, right? Just keep on going like this, like multiply this thing by x minus 4, you will just have x power 4 minus 1 plus 2 plus 3 x cube plus so on, and then minus 4 for that, you will just have minus 4 x cube plus some other stuff. So once again, just plus 4 over there, and it keeps on going. So the 99 term, which is the second term for this expansion, that has the coefficient as negative 1 plus 2 plus 3 all the way till 100. Cool. And okay, so what is this value going to be? Well, I'm going to tell you it's 50-50. I mean, sorry, 5050, that's better. But how did we get to that value? So call this thing S. In fact, instead of that, just use a general series. So 1 plus 2 plus 3 all the way till n. So there are n numbers over there. So once again you write S, but now you write it like this: n plus n minus 1 plus n minus 2 all the way till 1, and then you add everything up. So I mean, you add these two equations up, so 2s equal to n plus 1. This is also n plus 1, that is also n plus 1, and keeps on going till n plus 1. So there are n of these, therefore 2s equal to n into n plus 1. So s is n into n plus 1 upon 2. In this case, n is 100, so our s will be 100 into 101 upon 2, which is 50 into 101, which is 5050. Cool. Okay, next you have the first term of an AP is 5, the last term is 45, and the sum of the terms is 400. So first term is 5, last term is 45, sum of the terms, oh, so the complete sum, that thing is 400. The number of terms is, so you can similarly do that thing. So yeah, our S value, that thing is just A plus D all the way till the last term, and which we can also write as the last term plus the last term minus the common difference, and keeps on going till you get the first term. There are n of these terms, so everything will match up perfectly, like this and this and this, everything will match up. And then just add these up. So 2s equal to a plus l, but how many of these a plus l? N of these, right? So s is a plus l upon 2 times n. This looks much more intuitive to me because a plus l upon 2 is the average of the first and last term. So you might just say that all of these were the same thing. If all of these were the same thing, then you would put a plus l upon 2 as the value of all of them, all of the terms, right? And now a is 5, l is 45 upon 2, and we don't know, s is 400, so this is 50. Cool. And that's going to be, that goes over to 800. 800 upon 50, that's like 80 upon 5, which would be 16, I think. So 16 equal to n. There you go. Next, if the ratio of the sum of n terms of two APs, okay, is 3n plus 1 is to 2n plus 3. So n is obviously like that, right? N is the number of terms, and the ratio is this thing. Then the ratio of their 11th term is okay, the ratio of their 11th term. Well, really, it's just that, okay, instead of writing L, we can write, we can write L as a plus n minus 1d, right? Look at this, the first term has 0d, then you have 1d, and so on, and eventually you should have n minus 1d over there. So like you should have a plus n minus 1d as the last term. Putting that into that formula, you will get s equal to 2a plus n minus 1d into n upon 2. Cool. Yeah, that looks right. Okay, and s1 upon s2, that's the ratio of the sums of the first and second APs. That will be 2a1 plus n minus 1 d1, okay, into n upon 2, and n is the same thing for both of them, so you don't have to worry about that. Okay, n minus 1 into d2. Cool. And n upon 2 as well. So you can write this as a 1 plus n minus 1 upon 2 into d1 upon a1 plus n minus 1 upon 2 d2. Oh, it should be 2 over there. And this is what? This is 3n plus 1 upon 2n plus 3, right? So from that you can find out what d1 and a1 is. Like you can find out everything, but that's not the aim of this question. We want to find a ratio of their 11th terms. So the 11th term of the first AP, that will be a1 plus 10 d1, and for the second AP as well, it's like 10 d2. Cool. And how do you get the ratio of these values? I mean, it looks very similar to this thing, except that instead of having n minus 1 upon 2, you just have 10. Hey, what if we put n minus 1 upon 2 as 10? Yeah, I mean, essentially you are putting n as 21. If we do that substitution in here, then yeah, we'll just get this ratio. And so putting that in this thing, just get 3 into 21 plus 1 upon 2 into 21 plus 3, I think. Yes, and that will be, okay, 63. Yes, 64 upon, once again, just 42 plus 3, 47, I think. Yeah. So So this is the ratio. If the roots of this equation are in AP, then its common differences. Okay, the roots are in AP. So say the roots are like alpha, beta, gamma. Then expanding this, you will just get x cube minus alpha plus beta plus gamma times x squared plus alpha beta gamma plus gamma alpha x minus alpha beta gamma. And comparing this thing with the polynomial that we are given, you can see that alpha plus beta plus gamma, that should be 12. So the sum of the roots is 12, but you know that it's in AP. So you can write alpha as beta minus d and gamma as beta plus d. And this sum is 12, right? So from that 3 beta equal to 12, beta equal to 4. Cool. Right, so now you know at least one of these. Yes. And their common difference is okay, so instead of that you just need to like find all of the values, I think. Right, so you need to find alpha beta gamma. This is problematic. At least we know one of the roots now, so it will be easier, I think. Let's try to do this thing. X minus 4, and that divides x cube minus 12x squared plus 39 x minus 28. Okay, cool. So x squared, x cube minus 4x squared, subtract that, 39x. Okay, this is gonna take some time. 7x plus 28, and yeah, 7 of course. So 7x minus 28, yeah, that works out nice. So this is the quotient polynomial, which is just x minus, it's like x minus 7 into x minus 1, right? So this whole polynomial, it was really just x minus 4 into x minus 7 into x minus 1. So alpha beta gamma are just 1, 4, 7. Okay, then their common differences is 3. Okay, next, 4 numbers are in AP. If their sum is 21 and the sum of their squares is 120, and the middle term and the middle terms are, okay, 4 numbers in AP, sum is 20, sum of the squares okay, is 120, and the middle terms are this is unexpected. Okay, fine. So what kind of AP would work? I think let's do this thing: a minus d, a plus d, a plus 2d, and a minus 2d. As you can see, this thing is in a, okay, this should be 3, I think. Then it would be an AP. Yeah, look at this. This is an AP, right? Over here the difference is 2d. This thing is also like 2d difference. This is 2d difference. Cool. Now what they are saying is sum of all of these is 20. So the sum of all of these is in fact is 4a. So our a is 5, and sum of the squares is 120. So this thing squared plus this thing squared, well, it's like a minus x squared plus a plus x squared, oops, a plus x complete square, and that will just be a squared minus 2x. Well, that's gonna get cancelled, so 2a squared plus 2x squared, really. So this whole thing, sum of the squares of these, right, that thing will be, well, a minus 3d square plus a plus 3d square, combine them, that will just be 2 times of a square plus 9d square. And similarly, you just have, combine these, you just have a squared plus d squared. So you can say like 4 into a squared plus, well, it's going to be 10, and then 2 is out, so 5d squared. What is this? It is 120. So a squared plus 5d squared, 30, and a is 5, so 5d squared equal to 30 minus 25, which is 5. So d squared is 1. D is either 1 or minus 1, right? So the middle terms are, so in both the cases you still get the same middle term, just the order is switched. So it's going to be 5 plus 1 and 5 minus 1, which is 6 and 4. Okay, if b plus c minus a upon a, and okay, all of this is in AP. Show that this is in AP. Well, one thing that we can do is b plus c upon a minus 1 comma c plus a upon b minus 1 comma a plus b upon c minus 1. If this is in AP, then just add 2 to each term and it will still be in AP, right? Because the difference didn't change, and that will just give us b plus c upon a plus 1. So like this same thing, just plus instead of minus. Oops, what's happening? Okay, plus 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 everywhere. Yeah. And now if we write it like that, it will just be a plus b plus c upon a plus b plus c upon b, a plus b plus c upon c. Now these three terms are in AP, but what that means is this difference, let's say it's d, then for these terms 1 upon a, 1 upon b, 1 upon c, the difference, this difference, that will just be d upon a plus b plus c, right? Yeah, of course. Yeah, you can try it like a plus b plus c minus that equal to d, and then divide this equation by a plus b plus c, and you will get this. Well, it's not an equation, but you can write it as an equation. And similarly, this is d upon a plus b plus c, and that means these are also in AP. So yeah, we did this. So next, let T1 be the rth term of an AP whose first term is A and common difference is D. Okay, T1 be the rth term of an AP. First term is A, common difference D for some positive integers. Okay, then you can say like T, what is this, TR, right? Rth term, it should just be R minus 1D. Okay, if for some positive integers m and n which are not equal, Tm is 1 upon n and Tn is 1 upon m. Oh, this is weird. Then a minus d is, so this is for some integers. Okay, fine. So what that means is a plus m minus, in fact I can just write this thing as a minus d plus rd, I think. So that will be like a minus d plus md equal to 1 upon m, and a minus d plus nd, that is 1 upon n. Then what is a minus d? I mean, you can write that in terms of m and n, but like you need actual values for this. How does that even make sense? Oh, come on. There could be so many of these, and like m is not equal to n. Okay, you know what? Subtract these two equations. That will just be d into m minus n equal to, well, subtracting that, just get n minus m upon nm, right? Yes, and that just gives us d equal to negative 1 upon nm, right? And putting that into this equation, just get a minus d. But that's just substitution. Like it won't, it will still give us the same thing. It doesn't give us a value, you know. So that's still not good, right? This doesn't make sense. You could choose any such, like, you know what, let's just prove that any series can be made from these two conditions. So let's say t2 is 1 upon 2 and t4 is 1 upon 4, and from these two conditions themselves I can make the whole series. So this difference, that will be 1 upon 4, right? Okay, it's negative 1 upon 4 because that's going like that. Okay, cool. And then half of that will just be negative 1 upon 8. So we can write this thing as 4 upon 8. This is 2 upon 8. And you know, midterm, that should be 3 upon 8. And then it keeps on going 1 upon 8 and 5 upon 8 and so on. Right. So what that means is you can create any, yeah, like you can have so many different APs where these two conditions are given. I mean, you can create the whole AP from that condition. So we just need to know what m value we are talking, what m and n values are, and from that will be done. Basically we will have the whole AP. Yeah, that means you just need to write a minus t in terms of m and n. So well, that's cool. Multiply this thing by n, or even better, like, okay, whatever, multiply this thing by n. So n upon m, and this thing with m, and subtract. So you just have m minus n into a minus t equal to, so now it's m upon n minus n upon m, which is m squared minus n squared upon mn, which is m minus n into m plus n upon mn, and then get rid of this thing. So a minus t, what am I writing, is, we can write this more beautifully like this. Oops. Yeah, nice. Next, the 19th term from the end of the series, 2 plus 6 plus 10 all the way to like 86 is, so from the end of the series, no big thing, just reverse this series and that will be 86. What's the difference? 4 is the difference, right? So 86, 82, and so on. And the 19th term, this is the first term, this is the second term, so it's like 86 plus 19 minus 1 is just 18, so I should say 18 into minus 4, right? 86 minus this thing is like 32 and 4 minus 72, yeah, and this is 4 and 1, so 14, I think. Okay, next, the nth term of the series are equal, then the value of n is, so n term of these series are equal, then the value of n is, fine, just to write the n term of series. This is going to be 3 plus n minus 1 into d, which is 7, and this is equal to 63 plus n minus 1 into, what's the difference? 2. Cool, this becomes 10. It goes over there, 5 into n minus 1 equal to 60, so n minus 1 equal to 12, n equal to 13. Next, if SR denotes the sum of the first R terms of an AP, then show that this thing is equal to 2R plus 1. Okay, S3R minus SR minus 1 on S2R minus S2R minus 1. Oh, this is bad. This is equal to 2R plus 1. I mean, okay, you know what, just write this like using the formula. So this will be 2A plus 3R minus 1D. In fact, you know what, write this as 2A minus D plus 3RD into 3R upon 2. That's S3R. Similarly, S2R, no, it's not 2R, it's SR minus 1. Right, that will be 2A minus D plus R minus 1. Okay, this is going to be R minus 1. D into R minus 1 upon 2. Like that. Okay, this is gonna get complicated. So if I take subtraction of these, like that's gonna be 2A minus D into 3R upon 2. Well, in fact, you know what, this 2 is gonna get cancelled anyway. So let's talk about 2 of these things. So 2 times that, 2 times that. So if I subtract these, this will be 2A minus D into 3R minus that, so it's gonna be 2R minus plus 1, in fact. Okay, yes, and what about this thing? It's going to be D into 9R squared minus R minus 1 squared, which is, wow, this is bad. Okay, so it's still just 3R squared minus 2 minus R minus 1 squared. That's like 3R minus R minus 1, 3R plus R minus 1. So 3R minus R minus 1, we know that's just 2R plus 1, and then the addition thing, that is 4R minus 1. So you can take 2R plus 1 common, and 2A minus D plus D into 4R plus 1. So okay, 4R minus 1. So notice what happened over here. This is the difference of these things, and this is the sum of these things. Same thing you can do for the denominator. So 2s 2r minus 2s 2r minus 1 equal to, so the difference of these two things is just 1, plus the sum of these two things, that is 4r minus 1 as well. So that's nice, 4r minus 1. You can see, taking the ratio, these two will get cancelled, right? And you will just have, well, I mean, this is also going to get cancelled, and you'll just have this thing, 2r plus 1. Yeah, we did this, we proved this. 150 workers were engaged to finish a piece of work in a certain number of days. 4 workers dropped the second day, 4 more workers dropped the third day, and so on. It takes 8 more days to finish the work now. Fine. The number of days in which the work was completed is okay. Okay, fine. Eight more days. Oh, so 8 more from the number that would have been if none of them dropped, right? So let's say a worker in one day does a fraction of work, and we denote that fraction by, I don't know, w. So 150 of these workers, that would be 150 times this fraction of work. So in one day, these people combined can do this much of work. So in whatever the original days were required, that would be 1, because these fractions would add up to become 1. Yes, right. And what else do you know? That now these are dropping, so 150w plus the next time 4 have dropped, so it's just 150 minus 4, so it's 146w, and it keeps on going like that. And now there's going to be 8 of these days, so there are going to be 8 of these terms. Yeah, you know what the first term is, you know what the difference is, so you can know what the sum is. So it's just 8 upon 2 into 2 of these things, like 300 plus n minus 1, so 7 into d, so it's 4, actually it's negative 4, right? Yeah, negative 4 into 7, yeah, so it's 4 into 300 minus what, 28, which will be 2, and that goes on 29, I think. Yeah, it's 27. Yes, that is right. Okay, this is equal to 1. Oh, this times w, of course, so whatever fraction they were doing, that's 1. But you already know that 150 w n naught equal to 1, so from that you can say n naught is 4 into 272 upon, yeah, I mean, this is weird, this is very weird. There's just 8 of, no wait, there's not 8 of these, there's n naught plus 8 of these terms, right? I could have made such a mistake though. Yeah, this is wrong. So this will be like n naught plus 8 upon 2 into 300 minus 4 into n naught plus 7, like that. That times w, that's 1. And at the same time you also know 150w times n naught is 1, and then dividing these two you can get n naught. Cool. So dividing these two, n naught plus 8 into, we'll just write this thing as 150 minus 2 into n naught plus 7, that's better. And this thing, we'll just write this is equal to 150 n naught, there you go. And this just gives us n, 150 n naught, that's there, minus 2 into n naught squared plus 7 n naught, and then plus 8, so 8 times 150, that is 8 and 40, that's 120, yes, minus 16 times n naught plus 7, right? This thing is 150 n naught, so this cancels. Cool. Did I do this correctly? I think I did. Okay, so that just goes over divide by 2 first of all, and that will be n naught squared plus 7 n naught plus 8 n naught plus 8 times 7 is like 56, that is equal to 600. Cool. So n naught squared plus 15 n naught equal to 600 minus 56, right? Which is, so 4 and then 9 is like 4 once again, 544. So basically n naught into n naught plus 15 is 544, and maybe we can write this as, I don't know, okay, 544. What's the square root of 544? It's bigger than 20, of course. Okay, so let's try with 20. Who knows, that might work. So like 20 into 2, okay, 35. This is 15. Oh, this is not going to work. You just need to split this, and this can is 4 into 454. It's like 1 and then 14, so just 3, 136, which is 4 into 4 into 34. Okay, so 16 and 34. 16 and 34, not a good idea. What else can you do? It's like 4 into 4 into 2 into 17. Yeah, that's all there is to it. Like 17 into 8 into 2, sorry, 16 into 2 is like 32, I think. Oh yeah, this works. 17 plus 15 is 32. So n naught is clearly just 17. There are 2 roots, but you got 1 root, you don't need the other, because the other root is probably negative or something. So there you go. N naught is 17. Wait, n naught is 17, so the total number of days are like n naught plus 8, that would be 25. Oh, 20, oh, 13th is remaining, yeah. Okay, the sum of n terms of an AP is this thing, then m is, okay, fine, tm, that's like the term, the mth term is this thing. So Sn is 3n squared plus 5n, but Sn minus 1, which has every term except the last term, the nth term, yeah, that will be 3 into n minus 1 squared plus 5 into n minus 1. So that gives us the nth term is 3 into n squared minus n minus 1 squared. So subtraction 1, addition 2n minus 1, so 3 into 2n minus 1, and this thing is just 5. So this is 6n minus 3 plus 5 plus 2. So Tm, which is 6m plus 2, is 164. That means 3m plus 1 is, what's this, like 82? This is going to be 81. M is 27. So M is 27. So this was the first exercise. Let's see. First thing is 24. Then, well, it's negative 50-50. Oh yeah, the coefficient is negative. So I don't know if I need to put this as incorrect or correct. I'm just gonna leave it like that. 16. Yes. 64 is to 45. No, I got a different thing though. So you just put 21, right? 21 times 2 is 42. 42 plus 3. You do put 21. What's the big deal about it? It's like 63 plus. It should be 64 upon 47. What could go wrong? Just put 21 into this, and I guess with 40. Oh no, 42 plus 3. That's 45. Calculation error. This is unfortunately wrong. right? So 2n plus 1, when you put n equal to 21, that's 45. So this should be 45. Yeah. Okay, fifth. Plus minus 3. Yeah, I mean, you can write the AP as upside down, and that will be negative 3 in that case. So cool. Sixth, 4, 6, yes. Seventh. Oh, seventh is not there. Eighth. Wait, what? It's 0? This doesn't make sense. This definitely doesn't make sense. Why would A be equal to D? Wait, this doesn't make sense at all. Why should it be 0? Why should A be equal to D of all things? No, it doesn't make sense. Oh, come on. It definitely doesn't make sense. What was that? A minus t plus md equal to 1 upon m, and a minus t plus nd equal to 1 upon n. Subtracting this, we just have m minus n d equal to n minus m upon nm. So d is negative 1 upon nm, right? And let's just put that over there. So that will just give us a minus d, and that will be negative. So it's like 1 upon n plus 1 upon n. There you go. This is not equal in any way. No, it is just not 0. This doesn't make sense. Let's try with our example. What was that? 1 by 2, which was basically just 4 by 8. And yeah, this was the second term. The fourth term was 1 by 4, which was 2 upon 8. It should be 3 upon 8. And in that case, the first term, that would have been 5 upon 8. And the difference would be 1 upon 8. So that's definitely not 0. So 8 is, it's just wrong. Right. This is wrong. 9th. This is correct. Okay. 10, 13, yeah. 11, 25. 25 and 27. Oh, that's 12. Because 11 is a proof question. So, yeah. Okay. Next. Geometric progression. If x, 2x, 3x are the first terms of an GP, then its fourth term is right. The same thing. Now it's a common ratio. So 2x plus 2 upon x equal to 3x plus 3 upon 2x plus 2 equal to some ratio. You just need to find what the ratio is. What these numbers are, will be done. And you can put that over there and this over there. And that will be 2x plus 2 squared, which is 4 into x squared plus 2x plus 1 equal to, well, 3x plus 3 is like, oh, well, 3x plus 3 is just x plus 1, right? What then? So you already know what r is, because this thing, it's just 3 by 2. Cool. Yeah, that means 4x plus 4 equal to 3x. So x is negative 4. That is weird. Fine, x is negative 4. Putting that into this, you just get negative 4, then multiply by 3 by 2, so it's negative 6, and then this is negative 9, and so on. Then its fourth term is, so this will be that times 3 by 2, right, which will be negative 27 upon 2. Okay, the nth term of a GP is 128, and the sum of its n terms is given. If its common ratio is 2, then the first term is, nth term is given. Yeah, sum of the n terms. So what's the sum of the terms of GP? So s equal to a plus ar plus all the way till ar to the power of n minus 1. This will be the last term, right? or you could just go like this, who knows. So its common ratio is 2. You can say like if you start with this, then the ratio would be 1/2 or something, but yeah, we'll just start like this. Okay, whatever. And then s, we can say s times r, that will be ar plus ar squared. The same thing will also be doing in agp, so keep this process in mind. And that will be s into r minus 1 is, so these will just get cancelled except this thing, so ar power n minus a, and there you go. S is a into r power n minus 1 upon r minus 1. Right, now in this case I'm going to intentionally write the gp from the last term to the first term. So the last term is 255, then 255 upon 2. Oh wait, the last term is 128. Yeah, so it's 128. Hey, you know what, 128 is 2 power 7, I think. Is it 2 power 7? So 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8. Power 5 is 32. Yeah, 2 power 7 is 128. Oh, that's it. This is the nth term. This is the last term. Oh, this is weird. Yeah, man, knowing a bit of binary numbers, you can clearly see that the next would just be 256, and all of these combined, they would be one less than that. I mean, I know that, but you don't, right? So I'm just going to prove everything. I mean, I'm going to do it in the classic way. So let's just write this upside down. So we'll start with 128, then this will be one less than that. So like you're starting with 2 power 7, then it's going to be 2 power 6, and then so on till what, till n terms. So this will be the first term, in this case the last term, but yeah, into 1/2 to the power of n minus 1 upon 1/2 minus 1. Right, and what's this thing? This sum is 255, which is pretty much just 200 and, so it's like 2 power 8 minus 1. Right, this will be 2 power 7. This is just 1/2, right? And that's going to be 2 power 8 over there. So 2 power 8 into 1 upon 2 power n minus 1 is 2 power 8 minus 1. Divide this thing by 2 power 8. And that will be 1 minus 1 upon 2 power 8. Oh, this should be negative over there. So this would be negative. Yeah, and that will just be 1 minus 1 upon 2 power n. So clearly n is 8. Okay. Its first term is, so its first term would just be, what's the last term? The last term was 128, which is just 2 power 7. So 2 power 7 is the first term times r, which is 2 to the power of n minus 1, which is 7. So yeah, first term is 1. Okay, if the first, second, and eighth term of a GP are respectively this, then the value of n is, this is the first term, this is the second term, this is the eighth term. A is n power negative 4, AR is n power n, okay, and what, second and eighth term, AR power 7, that is n power 52. From these two you can get what r is. So r power 7, that thing is just n to the power of what, 56. So r is, it's an odd number, so this works. It's not plus minus over there, it's just n power 8. Cool. So putting it into that into this equation, it's like n power minus 4 times n power 8, that's just n power 4 is n power n. So n is 4, or n is 1, in which case the whole thing would just collapse. Value of n is probably 4 or 1, but if it's 1, it's not a GP because it's just all of them are just 1. Okay, next. let ABC form a GP of common ratio R. If A, 2B and 3C form an AP, then R equals ABC form a GP. That means so B squared equal to AC. You can derive this on your own, right? It's just B upon A equal to C upon B. From that you can get this equation. Similarly, for the AP you can get 2 times of 2B equal to A plus 3C. I don't need to guide you for this small step. Yes. Okay, so these form a GP with common ratio R. You know what, instead of using this equation, I'm just gonna say that B is AR and C is AR squared, and put that into this equation. That will be 4B, which is 4AR equal to A plus C is AR squared, so 3AR squared. So 3R squared plus 1 equal to 4R. Clearly R equal to 1 works, right? So maybe just the ratio is 1. The other solution, what's that going to be? So it's just 3R squared minus 4R plus 1 equal to 0. Looks like 3R minus 1 into R minus 1, I think. Yeah, looks right. So other solution is just R equal to 1 by 3. Cool. Next, if the sum of an infinitely decreasing GP is 3 and the sum of the squares is 9 by 2, the sum of the cubes of the terms is okay, infinitely decreasing GP. So it's AR squared, so on, right? You know this formula, it's just 1 minus R power n upon 1 minus R, and since it's infinite, you have n equal to infinity, but it's decreasing, so R is like between 0 and 1. So something between 0 and 1 to the power of infinity, that is approaching 0, so it's gone. So A upon 1 minus R, that's what this infinite GP will turn out to be. And okay, this is the first thing. So this is 3, sum of its squares. So the squares would be A squared, R squared, so on. So this will have this sum as A squared upon 1 minus R squared, right? Because A squared is the first term and the ratio is R squared. And what is this? This thing is 9 by 2. And we just want A cube upon 1 minus R cube, right? Because this is the sum for A cube, R cube, so on. What's this going to be, right? Okay, you just need to know what R is for this. So A upon 1 minus R, that thing is 3. A squared upon 1 minus R squared, that thing is 9 by 2. Just divide this thing by that, right? So if we divide this, that will give us A upon 1 plus R, right? Do the division correctly and you will get this thing. This is equal to 3 upon, I mean, of course this cancels, and then 1 minus R squared upon 1 minus R, that's just 1 plus R. And yeah, that's nice. And using it with this equation, actually just take the reciprocal of both of these. So 1 minus R upon A, that thing is 1/3, and 1 plus R upon A, that is 2/3. Okay, so you can add these up, that will just be 2 upon A equal to 3 by 3, which is 1. So A should be equal to 2, and you can subtract, so you just get 2R upon A equal to 1 by 3, but A is 2, so this is gone. So R is 1 by 3 and A is 2. So our sum, that would just be A cube, which is 8 upon 1 minus R cube, which is 1 minus 1 upon 27. So it's like 8 upon 26 into 27. 8 upon 26 is just 4 upon 13 and 27. So this will be 8 and 28, which is 108. Yes, upon 13. Cool. So 108 upon 13. Okay, next. Sum of the first two terms of an infinite GP is 1. So A plus AR is 1. Okay, and every term is twice the sum of all the successive terms. So AR power n minus 1, that would be the, actually no, just talk about AR power n. This would be the n plus 1th term. This is the sum of all the n terms that came before it, which would be a into 1 minus r power n upon 1 minus r. So these are the two equations that you have. This cancels, and this is for all values of n. Okay, that just tells us that r power n minus r power n plus 1 equal to 1 minus r power n. This is weird. This is just so weird. Wait, it's twice the sum, so this is actually 2 times of that. So this should be 2 minus 2r power n, and that goes over there, just 3r power n minus r power n plus 1 equal to 2. Yeah, come on, think about it. R power n plus 1 minus 3r power n plus 2 equal to 0. This, I don't think it's like factorizable in any way. Yeah. Okay, what do you want? And its first term is, okay, you just know this thing, so just know that a is 1 upon 1 plus r, and you need to find what this value is. But how am I going to get that? And this is like for all values of n. Okay, for all values of n, you say. So it's also for n equal to 1, right? So it's r squared minus 3r plus 2 equal to 0. That means r is 1 or 2. Oh, that was nice. If r is 1, yeah, this doesn't make sense. If r was 1, then a would be 1 by 2, and this would be 1 by 2, 1 by 2, 1 by 2. You can clearly see that this is not the sum of these two. So this is not correct. Other case would be if r was 2, right? Wait, but how can that be? R is 2. Okay, so a would be 1 by 3, and this would be 1 by 3, 2 by 3, 4 by 3, so on, right? So add these up, just get 1, which is definitely not what this is. Okay, it's not 2 by 3, it's 2. It's 2, which is basically 6 by 3, right? So this will be 7 by 3, 14, no, 6, right? So 13 by 3, and so on. And this plus that was like 8 by 3, and it's still not working. It's just not working. 6 by 3, that should be 13 by 3. What else could it be? Oh, it's the ratio. What am I doing? Just what am I doing? It's not an AP, it's a ratio, right? So it's 1/3, and then 2/3, and then 4/3. But this doesn't make sense because no, something's not correct about this. 1 plus r should be 1 upon 1 plus. This just cannot be. How can this be? Every term is twice the sum of the all successive terms. That gives us, like, for n equal to 1, so for the third term you will have ar squared. That thing is ar plus a, right? That just gives us r squared equal to 1. Hey, no, it should be 2 times of that, so it's 2 times of all of this. What is this? Why is this so problematic? Why did this 3 come out of nowhere? That goes over there. Oh, come on. What's wrong? Why is this It should be n terms, right? Oh, this is n minus 1. Okay, that's where I went wrong. This is supposed to be n minus 1. Oh no. Then this thing for n equal to 1 would be very different. It would be r minus r squared equal to 2 minus 2. Wait, no, that's not right. It was like n equal to 1 is just about 0. That what is wrong? What is just no, it's got to be n terms. It's got to be n terms because this is the n plus 1th term, so it just has to be n terms, right? And this means it's like that, but that means it's that negative 3 going over there, and this makes no sense at all. What happens when this is 1? That just means 1 minus r upon 1 minus r. That means it's 2. So like r power n equal to 2, where n is 1. How does this satisfy that equation? It's just, yeah, it's like negative 1s. That turns out to be okay. But then if you multiply this, it's just r power n minus r power. Oh, could it be that this is also giving us 2 as a solution, and that is also giving us 2 as a solution, and yeah, maybe that is how it is. So it's r squared equal to 2r plus 1, so r squared minus 2r minus 1 equal to 0. But this doesn't, oh, this is supposed to be 2 over there. Okay, but how does that make sense? This is frustrating. This is for the first term, which would be, how many terms are there though? You can't just put n equal to 1, right? Yeah, I mean, like, no, if you put n equal to 1, you will get a different n equal to 1. That would mean that the second term would be equal to the first term. That's not correct. You can't put n equal to 1. Oh, this is wrong. Instead, you have to put n equal to 2 in there. So putting n equal to 2 in there, you just get this equation, which means r equal to minus b2 plus minus square root of b squared, which is 4 minus 4. It's like plus 8 upon 2, which is 1 plus minus square root of, it's like 1 plus 2, which is square root of 3, right? So r is either 1 plus square root 3 or 1 minus square root 3, and this should be going for like all values. So let's just also go for a third. So it's going to be r power 3 equal to, right, that's the fourth term. This is equal to 1 plus r squared plus r third, no, just r squared, yeah. And okay, this is a cubic equation, which is not a good thing. You can definitely write this thing as r power 3 minus 1 upon r minus 1. That going over there just is r power 4 minus r equal to r power 3 minus 1. Oh wait, r power 4 minus r power 3, right? So r power 4 minus 2 r power 3 plus 1 equal to 0. That's still not going to work. This is very similar to this equation. Just now it's like biquadratic. Oh, come on. But what you already know is like r squared is 2r plus 2. Maybe we could use this thing and also this thing to do some, oh, it's supposed to be 2 times of that as well. Yeah, so putting r cube as r squared times r, you just get 2 times of r plus 1 into r. That thing is 2 times of 1 plus r squared, and that is just r plus r squared is 1 plus r squared. That makes no sense at all. Oh, come on. Why is this? I think we can only conclude that there's no such series. Right. What else can we even do about this? This makes no sense. I mean, look at this. You got r cube equal to that, but at the same time, r squared is just 2 times of 1 plus r. And then putting that in there, just get 2 times of 1 plus r times r. And that gives problematic stuff. So this just cannot happen. Yeah, that's the thing. It just cannot happen. Right. Okay, whatever. I'm just gonna go to the next question. Find the least value of n for which this thing is bigger than 1000. This is not that bad, just 3 terms. So it's 1. Okay, wait. The first term is 1 times 3 power n minus 1 upon 3 minus 1. Bigger than 1000. Or in other words, 3 power n is bigger than 2001, right? So 2001, like 3 power 0 is 1, 3 power 1 is 3, 3 power 2 is 27. Okay, 3 power 4, 3 power 6 is 3 times of that, it's like 9, 2, 1 carried on, 729. Okay, 3 power 7, that would be 3 times of that, it's like, look at it, 7 times 3 is 21 and stuff, so it's definitely is bigger than that. So n should be 7, that would be the minimum value. Yeah, just calculate this thing. It's 7, 2 carried on, that's like 6, it's like 8.2187. Yeah, next. 3 numbers from an increasing GP form an increasing GP. If the middle number is doubled, so if this is like AR squared, or instead it says like A upon R, AR and AR squared. Oops, not AR. A and AR. This is the GP, for example. If the middle number is doubled, so now you got 3A. And now these numbers are in AP. What that means is 4 equal to, because like of course that these being in AP of course just means that 1 upon R, 2 and R in AP as well, right? And that means 4 is R plus 1 upon R. So R squared minus 4R plus 1 equal to 0. Is this correct? I think so. And from that it just becomes R equal to this thing, which is 2 plus minus square root of 4 minus 1, which is square root of 3, right? And this is supposed to be an increasing GP, R equal to 2 plus square root 3, just like that. Hey, in that question, what will we get? 1 plus square root 3, that's not correct. Just if it was something different, because 1 plus square root 3 minus square root 3, they are not reciprocals of each other, so you can't say it's the same GP. Yeah, that won't work. But like of course we'll try to think that maybe it's the bigger number that we have to look at. So maybe like R is, you know what, let's try this once again. Maybe R is just 1 plus square root 3, who knows. Yeah, so if R is 1 plus square root 3, then will this work for every single number? I don't know. Every single n, R power n equal to R power n minus 1 upon R minus 1, where R is square root 3 plus 1, so square root 3 plus 1 to the power of n. Will this work for everything? Looks doubtful, you know. Square root 3 times that. Okay. It's like square root 3 plus 1 to the power of n times square root 3 minus 1. Wait, what? What else? That's equal to -1. but this is positive. How can that even be? Yeah, this makes no sense at all. Of course, it makes no sense. Oh wait, it was 2 times of that. Maybe that would make sense, like 2 times of that. So 43 minus 2 equal to negative 1, or the square root of 3 minus 2, you can write that as square root of 3 plus 2 and then square root of 3 plus 2 over there. So that's like 3 minus 4, that's just negative 1. So square root 3 plus 1 to the power of n is square root 3 plus 2 for every single value of n. That's not correct. No, that's definitely not correct. Oh, this is negative 2 over there, I think. Okay, wait. This would just be square root 3 times square root 3 plus 1. The power of n equal to 2 times the square root 3 plus 1 to the power of n. That means 2 minus square root 3 times square root 3 plus 1. Right, that just means square root 3 plus 1 to the power of n equal to 2 upon 2 minus square root 3, which is basically 2 into 2 plus square root 3. And this is for every single value of n, which is stupid because this cannot happen. So this question, where is it? Yeah, this question is just wrong. There's no way that this can actually happen, or at least no way I can think of. Yeah, anyway, about this guy, you have r equal to 2 plus square root 3. Okay, next, if the product of 3 terms of a GP is 216 and the sum of their products taken in pairs is 156, then greatest term is product of 3 terms in a GP is 216. That means the middle term, right? It's like a upon r, a and ar. Then a cube is 216. So a is 6. Sum of their products taken in pairs. Taken in pairs, that means first this, so this will be a squared upon r, then this, so a squared r, and then these, which will just be a squared. It's 156. Then the greatest term is, so a is 6, so a squared is just 36, so 1 upon r plus 1, that is 156 upon 36. 156, that is, I think 12 and 36, so like 6 into 2, it's 26, right? This is just 6 into 6, cancels. That will be 13 upon 2. Oh, 13 upon 3, sorry. This is 13 upon 3, and that just means 1 upon r plus r equal to 13 upon 3 minus 1, which is 10 upon 3. What am I writing? 10 upon 3. That means 3r squared plus 3 equal to 10r. So 3r squared minus 10r plus 3 equal to 0, right? So you can split this as 10r, 3r squared minus 9r minus r plus 3 equal to 0. So r minus 3 into 3r minus 1 equal to 0. So either this ratio is 3 or 1 by 3. Both give us the same thing. So middle term was 6. If this ratio was 6, if this ratio was 3, this would be 2, 6 and 18. Greatest term is 18, of course. Let this guy be the nth term of the GP of positive numbers. What? Let an be the nth term of the GP of positive numbers. Okay, that just means an is ar power n minus 1. Let this summation from 1 to 100 of, okay, fine, that is alpha. So from 1 to 100, you say, that will be a times r power 100 minus 1 upon r minus 1. That's alpha. And a, wait, what is, it's not n, it's 2n. Oh, this is bad. So it's a2, which it's like, okay, a2 plus a4 plus all the way till, yeah, it just keeps on going. And this thing is alpha and this thing is beta, a1 plus a3 all the way till 100. So there's 100 terms of these, 100 terms of that. Show that the common ratio is alpha upon beta. Right, it's not a big thing because a2 is just a1 times r and a4 is a3 times r, and there's exactly 100 of these terms, so everything matches up. The last term, which probably is like a sub 200 I think, and this is like a sub 199, so this also matches up r. Yeah, that's very clear that alpha is just r times a2 all the way till not a2, a1, all of the odd ones. That's gonna be r times beta. Cool, this was easy. Sum of first two terms of a GP is 1 and every term of this series is twice of its previous term. Okay, sum of first two terms of a GP is 1. Wait, is the same question as that? Wait, every term of the series is twice of its previous term, not the sum of the previous term. That just means the ratio is 2. Right, this is a different question. That was a different question. Right, r is 2 and the sum of the first two terms is 1, so a into 3 is 1. A is just 1/3. And the first term will be 1/3. What's the big deal? Right. Okay, if a, b, c are in AP and mod a, mod b, mod c are less than 1, and okay, this thing, show that x, y, z are in HP. Well, x is just 1 upon 1 minus a and y is 1 upon 1 minus b and z is 1 upon 1 minus c. Right, using the formula which is derived, and from that you have 1 minus a equal to 1 upon x and stuff, so that just gives us a equal to 1 minus 1 upon x. But a, b, c are in AP, that means 1 minus 1 upon x, 1 minus 1 upon y, 1 minus 1 upon z are in AP as well, but you can cancel these ones out because the difference still remains the same, and then multiply each term by -1 because that makes a difference. Right, this difference just become, if this is d, then 1 upon x, 1 upon y, 1 upon z, this will have difference -d, and this will also have difference -d. Right, so it's still an AP. So yeah, like reciprocals are in AP, so they are in fact in HP. These are in HP. Cool, it's done as well. So let's see. First is -1/2, yes. 1/3, 4. Fourth, 1/3. Fifth, 1/13, yes. 3/4. 3/4, you say. First term is 3/4. Okay, it's like 3/4 plus 3/4 r equal to, why does this, like, how does this even make sense though? Does the first term even matter? Oh, actually it does, because the sum of first two terms is 1, that's given, so that means 3/4 equal to 1 upon r. Okay, this is weird. So plus 3/4 r equal to 1, that means 3r is 4 minus 3, which is 1, and r is 1/3. Okay, how does this make sense? R being 1/3, what does this even do? Like, does that make a difference? 1/3 to the power n equal to 1 minus 1/3 to the power of n upon 1 minus 1/3 for all values of n? Looks unlikely because it's, oh, 2 times of that, of course. So is this always going to happen? This would just be 2/3 and this will cancel, so that just gives us 3. Instead you can make that 1/3 go in that way, so 1/3 power of n plus 1 equal to 1 minus 1/3 power n for all values of n. No, that doesn't make sense, because, or does it? Oh, that's, No, that got cancelled, right? That definitely just got cancelled. Right. So that's 1/3 to the power of n into 1/3, I think, plus 1. It's like 4/3, and that's equal to 1 for all values of n. That's stupid. It just cannot happen. So yeah, like, why did they put this kind of question over there? I don't get it. This just cannot happen. 7th, 7, yes. 8, 2 plus square root 3, there you go. 9th, 18, 10th, and that's just a proof question. This is also correct. This is also a proof question. Okay, and in chapter exercise 3, find the 7th term of the sequence. Now this is like harmonic progression, I think. Okay, find the 7th term of this sequence. Okay, I think it's harmonic progression. Yeah, I mean that. Oh, this is not the correct color. So this is 1 and 6/3 and then -7. You can write this as 3/3, in fact. That doesn't make sense. Okay, 1 is better. Or maybe you can write it as like 6/6. Okay, and then -7, which is, this is very different than what I was expecting. This is 1, this is 7. Oh, this is 7/3. This is different. -7, and then -5. 5 plus 7 is like -7/5, so on. 7/-1, 7/-5, so on. Clearly you can see 7 to 3 it's -4, 3 to -1 is -4, it's -4, so it's just an HP. Just want to find the 7th term. This is for the first term. So for the 7th term, it will be, the denominator will be 7 plus 6 times -4, which is 7 minus 24, which is negative 17. Yes, so 7/-17 is -7/17. There you go. Wrong color. Next, a2 equal to 1/2, a5 equal to 1/11, and find the value of, right, yeah, just convert this HP into an AP by taking the reciprocal. Just call that B. So B2 equal to 2, B5 equal to 11. Just want B1 plus B2 plus B3 all the way to 20. B20. Cool. So you can find what difference is. So 2 to 5, that's 3 jumps, I think. So it's 3D of difference. That will be 9. So difference is 3. There you go. Do a jump backwards. So B1, that will be -1. Right. So it's just -1 plus actually 2 times of that, right? Yeah. So it's, how many terms are there? There are 50 terms. So 50/2 into a plus l, which we can write as 2a, which is -2, plus n-1, which is like 49. In fact, you just write this as 2a minus d. So d is 3 minus 3, and then plus 50 times 3, I think, right? And d. Cool. This is the sum. Let's calculate this thing. So 50/2 into -5 plus 150. So it's 145 into 50/2. Yeah, it's like 145 into 25. Wow. Now what do we do? So 5 to carry on, 70, 725. Yeah. And 28 and 10, 290. 5, 2, 6, 1, 3, 6, 2, 5 should be the value, I think. Okay, next. If a, b, c bigger than 1, x bigger than 0 are in GP, then show that this thing are in HP. these are in GP, show that these are in HP. Okay, so you know, like log base A of B, that can be written as 1 upon log base B of A, right? You should be knowing that, because of course log base A of B can be written as natural log B upon natural log A, right? This thing always works. Or I can say log base C of B and log base. So just taking the reciprocal, you can say that 1 upon log base A of B, that's log base B of A. You know this identity. And if you don't know this, well, okay, should I prove this or not? Maybe I should prove this. Nah, whatever. Just search it on Google, you will find a good proof maybe. So using that, we can write this series as 1 upon log base x of A and 1 upon log base x of B and 1 upon log base x of C. This should be in HP. That means that these must be in AP. But these being in AP means ABC must be in GP, but they are already in GP. So yeah, this is obviously true. Cool. If x, A and y are in AP, x, B and y are in GP, and x, C and y are in HP, prove that the quadratic equation. So just find A, B and C in terms of x and y. So A is the average, B is the geometric mean, which is square root of xy. C is the harmonic mean, which is 2 upon 1 upon x plus 1 upon y. This is how the harmonic mean is found. For multiple numbers, it would just be n upon 1 upon x, 1 plus 1 upon x, 2 all the way till 1 upon x to n. That's how the harmonic mean is found. It's more like the mean of the harmonic terms, right? You take the mean of the harmonic terms and make that equal to another harmonic term, and then you find what the actual term, okay, whatever. It's just the way it is. Okay, and this can be done as 2 times of x plus y. Oh no, this is not correct. It can be done as 2 times of xy upon x plus y. But x plus y upon 2, that's just a, and xy is b squared, so it's like b squared upon a. So you just got b squared equal to ac, like that. Okay, cool. And what we have to prove is that this guy has equal roots. Well, this guy's discriminant, sorry. That thing is just 4b squared minus 4ac, which is 4 times of b squared minus ac. But guess what? B squared minus ac is 0. So there you go. If p term of hp and q bq, okay, getting it. Right. So if I convert it to the corresponding AP, the pth term of that AP is 1 upon q, and the qth term of the AP is 1 upon p. Then show that it's p plus, wait, maybe it could be that previous question of m and n, where like the reciprocals of m and n are the terms in AP, it was different order. Oh yeah, it was a different order. This is, can't believe I made a mistake over here. Just solve this once again, What was this question? Let's read this again. So TR is the rth term of AP whose first term is A and common difference is T. For some positive integers m and n, Tm is 1 upon n, not 1 upon m. So A minus D plus md is 1 upon n, and a minus t plus nd equal to 1 upon m. This is a big difference. And then if you subtract this, you just get m minus n d equal to 1 upon n minus 1 upon m, which is m minus n upon mn. So t is 1 upon mn. And if you multiply this by let's say n, so like a minus t times n plus m n d equal to 1 upon n squared, and m times of a minus t plus m and d 1 upon m squared, and subtract these out. So m minus n into a minus t, that thing will be m squared minus n squared upon m squared n squared. That means a minus t is m plus n upon m squared n squared. Yeah, I mean, it's still not the same thing, in fact. Yeah, something's weird about this. Oh no, you multiplied by n, not divided by it. You should do this 1 and 1. Yeah, in that case, if you subtract this, you do get 0. So this in fact equals 0. So this is actually correct. Okay, fine. Next, I mean the question which we were doing before this realization, and this was done. Yeah, where was I? Okay, if p term of an HP, PQ and Q term BP. So you already know this, in fact, that A equal to D, right, for the corresponding AP. So for the corresponding AP, you just have AP is 1 upon Q and AQ is 1 upon P, right? So you know A equal to D, right, from previous thing, and you want to know what the P plus Qth term is. So what's the Pth term really? It's just, if the difference is in fact equal to A, then the Pth term is just P times A, right? It's P times A. I think that's correct, and this would just be Q times A. So that means PQ A equal to 1, like A is just 1 upon PQ. Cool. And now we can find what P plus Q term is. So P plus Q times A, but A is just 1 upon PQ. And this is equal to 1 upon P plus 1 upon Q. That would be for the arithmetic progression, but now you just need to take the reciprocal of that to get the actual harmonic progression. So this will be 1 upon 1 upon P plus 1. I mean, yeah, just PQ upon P plus Q. Wait, no, it's not that. Okay, P plus Q. Something's not right about this. PQ equal to, I don't get it. It's PQ, P plus Qth term is P plus Q? No, how could that be? It doesn't make sense. The Pth term, I mean, like A is equal to D. It should obviously be that the Pth term is P times A. What else could it be, possibly? I don't know, man. This just is equal to. Something's wrong. Something is wrong about this. Come on, think. A is equal to D. It should be P times A. What's going wrong? Then you just want the P plus Qth term. So P plus Q term of AP, that will just be P plus Q times A, and this would be like that. Yeah, for the corresponding AP, that's just like that. Something's not correct, Unless, of course, PQ is 1, which cannot happen because these are like. Then why is this going wrong? Just start with, once again, like A plus. So for the AP, you just have A plus P minus 1 times D. That thing is 1 upon Q, I think you're right. Yeah, and similarly A plus Q minus 1D is 1 upon P, and then if you subtract that, just get what, like A minus D. Yeah, don't really subtract, just multiply by Q. So A minus D into Q minus P, that's 0. So A minus D is 0. So A equal to D, and putting D as A over here, just get what, P times A equal to 1 upon U. So A should be equal to 1 upon PQ, and then the P plus Qth term for this AP, that just be P plus Q upon PQ. So the harmonic term of this corresponding arithmetic term, that would just be PQ upon P plus Q. how is this equal to p plus q in any way? No, it doesn't make sense. Question mark. Next, if a, b, c are in AP and a squared, b squared, c squared and hp, show that c equal to a plus b. Okay, c equal to a plus b. So you know, like 2b equal to a plus b, sorry, 2b equal to a plus c, and these are in hp, that just means 2 upon b squared. This looks kind of not so symmetric. Yeah, okay, whatever. And 2 upon b squared, that's equal to 1 upon a squared plus 1 upon c squared, right? That means 2 times of a squared c squared is b squared times a squared plus c squared. Oops, c squared. But you know that b is just a plus c upon 2. So if I multiply this by, let's say, another 2, this will be like, now multiply by 4, so 8 a squared c squared equal to 4. Yeah, and then this is just 2b squared, but 2b is a plus c, so a plus c squared into a squared plus c squared. 8a squared c squared equal to a squared plus c squared plus 2ac into a squared plus c squared. But that's weird, because we can say this is x squared, and this thing is y. So x squared plus 2xy minus 8y squared equal to 0. So this is like x plus 4y into x minus 2y equal to 0. So x equal to minus 4y. X is what? X is just a squared plus c squared. This being equal to minus 4y means it's equal to minus 4ac. Or, but how can this be? I mean, like, okay, whatever. Either this is happening, or you have a squared plus c squared equal to 2ac. This equation, this would just mean that a is, like, a plus c is 0. Oh, that's weird. A plus c is 0, but that means b is 0, and this makes no sense in that case, because 1 upon 0 is not defined. So yeah, this doesn't make sense. Other thing would just be a squared plus 4ac plus c squared equal to 0. Then a plus c squared plus 2ac equal to 0. Well, this is weird. A plus c squared, that's like negative 2ac. Okay, so one of these numbers, a and c, one of these must be negative. That's all we can say. Okay, and we have to show that c is a plus b. From this equation, how can you show that c is a plus b? Think. Well, okay, you know what, instead of writing b, we can directly write a plus c upon 2. So it's like 2c equal to 2a plus c. We have to show this thing. In other words, we have to show that c is 3a, but okay, this is weird. A squared plus 4ac plus c squared equal to 0. How does this mean that c is 3a? No, it doesn't mean that. Yeah, just what is this? Why is this equation so unsymmetric? You know, this makes no sense. C equal to 3a. It's like, in that case, you just have a, 2a and 3a. Yeah, these are in AP squares. That would be 1 upon, if the squares are to be in harmonic progression, that would mean that 1 upon a squared, 1 upon 4a squared, and 1 upon 9a squared. These are in arithmetic progression. Is this correct? 1 upon 4 minus 1 equal to 1 upon 9 minus 1 upon 4. This is like negative 3 upon 4, and that would be 4 minus, it's like negative 5 upon 4. No, this is no way correct. How can this even be? This doesn't make sense. Now this is wrong. 5 numbers such that A, B, C are in AP, B, C, D are in GP. A equal to 2, E equal to 18, and the value of B, C, D are. Okay. If A is 2, and the value of B, C. Right. So you basically have to find everything. That's what you are saying. Oh, you also give us E, right? So A is what, 2, right? B, C, D and 18. B would just be 2 and 2 plus C upon 2 C, and then D would just be, what's this, CT 18, that would be in HP, right? So this would be in HP, like 2 upon D equal to 1 upon C plus 1 upon 18, which is 18 plus C upon 18D. So D is 36D upon 18 plus C. Okay, cool. So now what about BCD? Those are in GP, right? And that means C squared equal to 2 plus C upon 2 into 36D upon 18 plus C, which is 2 plus C into 18D upon 18 plus C. And that goes over there, just becomes 18C squared plus C cubed equal to, I mean, okay, wait, why is this D over there? It should just be 36C, right? There should be C over there. Wait, sorry. So either C is 0, which basically doesn't happen, or you have C equal to 2 plus C times 18 upon 18 plus C, which means 18C plus C squared equal to 36 plus 18C. This cancels, you got C squared equal to 36, C equal to plus minus 6. There you go, right? So find the values of B, C, D. Now you know what C is. You can find these. It's 2. If this is plus 6, then this will be 6 plus 2 upon 2, which is 4, and this is 6. And what is D? D will be 36 times 6 upon 18 plus 6, right, which is 18 plus 6 is like 4 into 6, so 6 cube upon 4 into 6, I think. Right, this cancels. 6 is like 36 upon 4, which is 9, and this will be 9 and 18, right? That would be one possibility, and other possibilities, like if it's negative 6, then this will be 2 and minus 2, I think. 6 and yes, it's minus 2 and then minus 6, and this would be 36 into minus 6 upon 18 plus C, right? So it's gonna be 12. Okay, this is minus 2 over there. This is negative 18. Cool. This is another possibility. BCD are 4, 6, 9, or negative 2, negative 6, negative 18. Okay, cool. The fourth term of HP is 3 by 5, and 8th term is 1 by 3, then its 6th term is. So the corresponding AP that has 4th term as 5 by 3, and 8th term as 1/3, sorry, 8th term as 3, and 6th term, that's just the mean of these, right? Because 4 plus 8 upon 2, that's 6. So the mean of these terms, just do the math, you will see that it's like, yeah, it will be 4D plus 8D upon 2, that's just 6D. So it's just A minus D plus 6D, and that's the 6th term, average of these two, and that will be 5 by 3 plus 3 upon 2, which is it's like 5 plus 9, which is 14. 14 upon 2 is 7. 7 upon 3. So the harmonic thing, that will just be 3 upon 7. Okay, just write it better. 3 upon 7. The roots of this equation are equal and show that ABC are in HP. The roots of this equation are equal. Okay. A into B minus CX squared plus B into C minus A into X. That means the discriminant is 0, basically. That's what we are saying. So B squared into C minus A squared equal to 4AC into B minus C into A minus B, I think. Okay, then show that ABC are in HP. Okay. Yeah, I just have to expand this. So B squared into C squared plus A squared minus 2AC times B squared, that's going to be equal to, you can write this as negative 4, or just pull that together. So it's going to be plus over there, and this is B minus A, I think. Yeah, that looks right. This is equal to 0. So this thing plus 4AC into B squared minus A plus C into B plus AC equal to 0. Cool. You know what, instead of doing all that, just take B squared common, and this will be C squared plus A squared minus 2AC plus 4AC, right? Cool. And then let's take B commons, and B only has one term, so it's like minus A plus C times 4AC times B, and then plus 4A squared C squared equal to 0. That's the equation. And this is B squared into A plus C squared minus B into A plus C into 4AC. Okay, cool. Plus, in fact, oh, I see what's going on. Plus 4A squared C squared equal to 0. You can write this as B into A plus C minus 2AC squared equal to 0. Look at that. Yeah, that's right. That means B equal to 2AC upon A plus C. In other words, it's the harmonic mean of A and C. So yeah, these are in harmonic progression. Okay. If the first two terms of HP are this and this, then the largest positive term of the progression is. First two terms are this, then the largest positive term. I mean, if it's large, it must be positive. So the corresponding arithmetic mean that just has the corresponding arithmetic progression that just has 5 by 2 and 23 upon 12 as the first two terms. What's this? 5 by 2, right? So it's going to be 12 and okay, what's 6 into 5 is 30. So it's 7. 7 is the difference. So the next term, that will be 16 upon 12, and then it's going to be 9 upon 12, right? Yes, it's 7, and then it's 2 upon 12, and then it goes to the negative numbers, and we don't want that. This is the smallest arithmetic term, and then its corresponding harmonic term will be the biggest harmonic term. That will be 6. Cool. Okay, let's check. First is correct. Okay, second is 550. Why? Two and 11, difference is 3. Sorry, difference is 9. So D is 3, yes, and this is just the sum. Why is this incorrect? I don't get it. It's like negative 1 plus 2 plus, I don't know, like plus 5, so on, right? How many of these? 20 of these. So 20 upon 2 into 2a minus t, so it's like 20 of the, oh no, I put 50 instead of 20. That's the whole problem. That, okay, minus d, so it's 3 plus 20 into our d value, so that's into 3. Yes, that's how it should be. Okay, 20 upon 2 is just 10, so 10 into minus 5 plus 60, and that's 55 times 10, which is 550, and that is this thing. This is wrong. Okay, I got it. So this went wrong. And third, this was proof questions. Okay, fifth and sixth, they just didn't give anything. Oh yeah, because these are like proof questions. Okay, bad luck. Seventh, -2, -6, 18. Yeah, that's one of the things. So this is correct. Eighth, 1 upon 7. Okay, calm down. Fourth term and eighth term of HP are given like this. Just 5 by 3 plus 3 upon 2, which is 9 plus 4 is, so 9 plus 5 is 14. 14 upon 2 is 7. 7 by 3. It should be 3 upon 7. What's the big deal, huh? It can't be 1 upon 7. How can it be? Yeah, this is wrong. It must be 3 upon 7. What else could be? Ninth, they didn't give. 10th. 7th term, the actual value of the term is 6. So, yeah. I mean the first term, whatever. I'm just gonna say it's correct. Anything else? Oh, there's still a lot remaining. There's 2 exercises that's remaining. And now it's over, like it's near 2 hours, I think. I should stop. Okay, I'll see you guys in the next video.